All right, so this is our civil engineering project for Chemistry 117. What is this project about? Civil engineering field deals with building roads, bridges, highways, and other types of infrastructure. Civil engineering affects coastal environments by building structures near the ocean, which disrupts ecosystems and the environment. Pollution and destruction from these infrastructures will continue to pollute the sea. This correlates with chemistry because these structures corrode over time due to seawater and other man-made factors.
Group issues, time management. The group struggled with poor time management, resulting in challenges in meeting deadlines and efficiency, utilizing available time. This impacted the overall progress of the project, requiring a closer focus on time, allocation, and coordination to enhance productivity and timely delivery. Coordination. The group faced issues with poor coordination, leading to challenges aligning efforts and streamlining tasks. The lack of synchronization hindered effective collaboration, causing delays and disruptions in the project's workflow. Improved communication and coordination strategies were identified as essential for enhancing overall group performance. How the issues were solved. Time management solution. Recognizing the difficulties caused by insufficient time management, the group devised a strategy to address the problem. They created a detailed plan, established clear milestones, and gave precise roles to each team member to maintain accountability. Regular check-ins and progress reviews were implemented. The group effectively turned around their time management challenges through greater communication and shared a commitment in achieving deadlines, resulting in improved efficiency and timely project completion. Coordination solution. Recognizing the efforts of poor coordination, the group created a clear communication strategy, defined roles, and instituted regular updates. Together with project management, these methods boosted collaboration and streamlined activities, resulting in more effective coordination and better project outputs.
Team members. My name is Rainier Mendoza, and my role is overseeing the completion of a final project, ensuring effective communication among team members, conducting quality checks on content and presentations, and ensuring timely delivery. I play a key role in ensuring a cohesive and polished final product. The team facilitator is Ethan Munoz. His role involves maintaining a structured timeline, encouraging effective teamwork, and ensuring ongoing communication with key stakeholders for continuous progress assessment. The project manager is Trevor Harbuck. His role is to guide team members in creating the video presentation content, ensuring alignment with objectives, assessing the team's chemistry, and monitoring the evolving quality of the product. The research facilitator is Sabrina Walker. Her role is to ensure the team members would conduct efficient and pertinent research, which validates the scholarly and appropriateness of all utilized resources.
Our group came up with 5 initial thesis proposals, which were: how can we make better infrastructure to withstand hurricanes? How can we improve infrastructure to withstand earthquakes? Are the buildings and roads optimal for withstanding extreme weather and create a hospitable environment for Galveston? How can we make ports and harbors withstand harsh environment? And lastly, how does the ocean environment affect the man-made infrastructure around it? And the proposal that we chose in the end was: how does the ocean environment affect the man-made infrastructure around? And the explanation for this is, we chose this thesis because it seemed like the best issue civil engineers would have to tackle and fix in an ocean environment. Additionally, this proposal is the easiest to research and provide strong evidence for due to the amount of infrastructure seen throughout the boat ride. Also, the explanations for this proposal is that civil engineers can apply coats of rust inhibitors to slow down corrosion for ships and boats. Additionally, civil engineers maintain offshore oil and gas rigs infrastructures by utilizing corrosion-resistant metals and shielding coats to protect materials below and above the sea level. Lastly, civil engineers prevent marine organisms from attaching themselves to ships, platforms, and pipes by using anti-fouling coatings and technologies on a variety of infrastructures.
And now on to our findings. So the first photo on the left is the SS Selma, and this relates to civil engineering because the seawater is corroding the ship because the ship is made of concrete and rebar. And in the second photo, the Pelican Island Causeway relates to civil engineering because one of the posts of the bridge is broken, which can destroy the bridge over time. And the seawater will corrode the concrete just like the SS Selma. And the third photo is Highway 45, and this relates to civil engineering because it is a bridge built over the ocean, and the bridge needs to be able to withstand hurricanes and ocean waves. So our scientific research. So one of the numerous problems that civil engineers have to consider when dealing with infrastructure around the ocean is marine life. So organisms such as barnacles, mussels, and algae can attach themselves to the structure of ships, platforms, and pipes, which can add weight and decrease the functionality of the structure. This occurrence, or biofouling, also increases the drag on vessels and leads to higher fuel consumptions. And in the case of underwater pipelines, it can restrict the flow of fluids and lead to corrosion of the pipe itself. To combat biofouling, civil engineers are forced to use an anti-fouling coatings and technologies such as the use of nanobubbles in pipelines that discourage the organisms to adhere to the material. This anti-fouling tech, however, has to be run through environmental regulations in order to curb the potential ecological harm, which creates an additional obstacle that civil engineers have to navigate around. Moreover, infrastructure projects in coastal areas can easily disrupt local marine ecosystems, and civil engineers must carefully consider the processes that can be used to mitigate disturbances such as artificial reefs or habitat restoration efforts. In summary, the challenges of biofouling alone include multi-step operations to both protect the environment and withstand the effects of marine organisms. And civil engineers need to learn to recognize these difficulties and integrate countermeasures to react accordingly. So in the top left of the screen is a picture of a cruise ship that has barnacles, mussels, and algae attached to it. And on the right is a ship with all the same things, which is the effects of biofouling. And flip to the next slide. And on this slide, we have our sources, 2 things in the picture. And that's all. Thank you.